messing with that. I'll start off with a brief introduction, and if live coding ends up being a little less live than what I planned, oh well, at least hopefully you guys get some information. And I think spread some ideas and that'll help. So what is, first of all, my name is Neil Funk. I'm with I3 Detroit, and it's my second year at Penguicon. And Will, yep, also his second year at Penguicon. So we're both programmers, more so than hardware hackers or than other interests. So the concept of live coding, basically, the core of it is you were writing code in front of people in real time, not like, hey, here's this program that I wrote, everyone looking at it. It has some, what's it?
Switch cable.
Well, can you give us a try just to see if maybe it isn't a laptop? Throw some pages.
Sure. Yes, to get to the network, because my network connection doesn't work today.
Well, if we can even get
we're testing some
video. So anyway, so compared to
my software.
Okay, so something with my laptop.
Yeah, because I want to use for this presentation. I have, it's a Linux variation of it, but it's has a few bugs in it. I'm like, yeah, I'm trying to cut down the issues as much as possible.
Okay. So this will be a little less live, but we've still got plenty of stuff to show you.
Yeah. We can. Yeah, some trucker with password here for the hotels internet.
Plug it into the
sorry, I'm late.
I don't want to turn this into a Linux fest. So let's tell you what. So
did you see players?
See if I can get that into it.
I don't think that we did the password.
Yeah, it was down earlier.
Now this is scheduled for some reason. This ended up being scheduled for like 2-hour blocks. I don't think we're going to need anywhere near that amount of time. I think this will be a fairly short information exchange of ideas, showing off a few things, and then if you guys want to get to like cardboard crossbows or something else, you're certainly more than welcome. But anyway, so the idea of live coding is compared to a performance of, say, recorded music where I'm going to press play and you're all going to hear the music out or something, versus I'm going to compose music in front of you, or say a live performance. And there's two aspects to that. There's a live performance of pre-rehearsed, practiced music, which you like to go see the orchestra or something. And then there's more of live improvisation. You see a jazz band or something, and somebody just makes up a solo. Either of those two analogies translate over into live coding. You can prepare a live coding program to write in front of people, and you can also improvise on top of that, making changes to the program. And the idea behind that is you're not programming something boring. Why would anybody want to watch you code a web app? Well, if you're at a conference where the conference is, here's how to code a web app, that's something that's becoming more and more popular rather than just having canned presentations. Someone's actually writing the code and saying, here live, we are live coding this web app, and I'm showing you for your knowledge. Which usually that does involve practice. You're going to go in and you're going to practice writing that web app to make sure you know all the steps, and you're not going to forget, like, oh yeah, I got to create a database, shoot. So you have a script, unlike me right now, and you rehearse it, and then you can convey that knowledge. What we're going to be talking about today, that's one half, but the other half is more of an artsy type of thing, live coding for entertainment, for art, for performance. And that's what this is about. There's a movement called Fluxus, F-L-U-X-U-S, and that's not just a live coding thing. That's a hippie artsy movement. If you guys want to Google it, but there's a Fluxes Manifesto, and this dates back to like the 60s. So anyway, the whole concept of Fluxus is like flowing, real world, real time, flowing art. Things like live installations of art, people doing candid video, making artsy candid videos of things, that sort of thing. Anything that's live, flowing, fluid, that kind of art, not static, basically, is the key there. So what we're going to talk about today is the intersection of those two things. You're writing code live in front of people, and the result of that code is something flowing, something changing, something artistic that people will be entertained looking at. So there are a couple different environments for this. One, did anybody go to the Scratch presentation? Yeah. So if you remember in part of that, at least in Scratch 2, apart from just using the logo commands to move a character on the screen, there's a bunch of audio things that you can plug together in Scratch. That's all visual, drag and drop, connect these things, make a loop, diagram it all out. And so there are actually people who have done not audio visual, but audio only live coding. And there's a visual aspect to it though, because you've got on the screen, everyone's seeing those big blocks that you're plugging together and moving around. And in response to that, they're hearing the music and how the music changes in response to the program. Anyone ever had that?
Already got it.
So that's not the real Firefox page, is it?
Yeah, this is the one that's basically on your hard drive. You install it.
I'll keep talking while we move through those technical difficulties, and just how about we tell you. So anyway, so there's audio only live coding, and that is sort of blurring the lines nowadays. You've got DJs and stuff who are improvising music on the fly. I don't know if you saw Inverse's chiptune stuff. Now most of his stuff is so in-depth and complicated that it can't be composed live, only performed live, in the sense where he's done all the work, he hits play, and you get to see the result. There's other audio environments that are at a higher level where you can actually be able to, in real time,
specifically chiptunes, computer-generated music and stuff like Last Night, or speak of music in general?
It's in music in general. It doesn't have to be chiptunes, although that's kind of those two genres kind of go nicely together. But you can do anything with recorded samples. Think of like free loops and stuff like that. Anything you can live. But generally, if you want to go with simple computer-made music, having simple sounds that you can plug together, it's just simple work. Now we show you joys of the video. Just like that. To the so show you. In so much as my horizon 4G was capable of. That should show us the right. So yeah, we should. So we'll get some visuals to go with this. And we do have some videos as well. So even if we're not going to be so much coding live. Okay, so I talked a little bit about the audio. Talking about the video, there's a couple different programming environments for doing live, actually coding basically. I mentioned Scratch, that's more visual coding. Yeah, why don't you just jump over to Wikipedia page real quick. Segue real quickly into some actual videos and stuff. So there's, if you want more reading, over there on the right there is the scrawled Marxist-looking Fluxes Manifesto, talking about how we're going to take art and rip it apart, cause a revolution. But so that's like I said, the 60s genesis of the concept. But now what we're doing is we're taking modern technology to actually implement that. Well, if you think about it, environment that I'll be talking about gets its name, its namesake. It's called Fluxus, spelled the same way.
Is there a real for here?
What's that?
Is that what I'm saying?
Yeah. Fluxus program.
Okay.
Now you can do live coding in any language. There's not necessarily a specific language. But what helps is if you've got a language and a runtime that's dynamically modifiable, things like rapid prototyping. Did anybody go to the demo scene? One that was early on Friday, or the whatever the one after it was, the chiptunes chill out. Okay, well, hey, then you won't have seen anything more impressive than this. Yeah. That's good. Those two probably should have been combined with this. But here's an example of the screenshot is an example of the Fluxus programming environment in action. And what you're seeing here, basically, the concept is you're writing, for lack of a better word, a Winamp visualization. That's how you can think of that. You guys ever just sit there and just zone out to watching that crap fly across the screen? So it's very much like, think of this as like the visual equivalent of trance music or something. Is often what you're kind of going for here. Oh yeah, there's no reason that we can't crank some music just for the heck of it. I got one of Inverse's Phase albums the other day.
So basically, I think what Neil's saying, only choosing this application because it has the visualization already turned on. And of course, as I said that, they are non-operational. And basically, going through your code like this and just imagine all the visualization at the same time.
Yeah, we got a couple pre-recorded videos that spin up from the Fluxus site.
Sure.
Can you flip it say for just a
No problem.
second? So the idea is you're not just seeing the Winamp visualization, you're seeing the code, and it's not, as we'll show you flipping back to the code. You can do it that way, and you can flip back and forth. But one of the nice things is that you can see. Oh yeah. But the idea is you have an environment that you can modify while you're while it's running. That's the key to the technology that's needed for this. I thought somebody talked about Python rapid prototyping games. That's basically the same idea as this. If you ever work on a game and compile, test, recode, recompile, retest cycle is a pain, and it's a hit on productivity. If you can modify something while it's running, you get that instant feedback, and that makes you not only productive as a developer, whether you're running Python web app and you're changing web service on the fly, that's pretty good. It makes you productive if you're doing a game like this, and you can change the physics of the game while you're playing it. And at the same time, if you're not playing the game, you can basically just be a audiovisual entertainment that you're then improvising and changing. So here and there, they're moving some stuff around. So and actually what this is showing is this Fluxus environment can be used for more than just live current performance, like rapid prototyping video games basically is what we're seeing here, an environment that they're able to change in real time and basically experiment with. Gary's mod, but with the code. Don't think about that one. Well, can you flip over to the other video?
Sure.
I think we made the point with this one. Go up. Screenshots.
You only saw that video.
What was?
Yeah.
There is a tutorial section here. Which, by the way, this is a great site with some great resources.
Maybe some documentation.
Yeah, actually, hold on. I have it right up on my
Tutorial movies?
Yes, that's the one. So even that very first tutorial will give you, better than I can explain it, you can see it happening.
is what you should have been if the technology was working. But basically, this goes into a full screen mode. It's a full screen text editor superimposed over top of the video output of running the code in real time. The language that you're seeing right here is Scheme. I don't know if you're familiar with Scheme or Lisp. Lisp dates way back to the it's Scheme. Are you familiar with? People
I know it exists.
Okay. Dates all the way back to the 50s, one of the very first very high-level language at a time when people were writing assembly. University professor comes up with this theory of computing. One of his grad students actually turns it into a compiler. And even the professor, this is I think McCarthy, was like, holy crap, I didn't know that could be a real thing. I was just writing a paper. So what you'll see is there's basically the syntax is very regular. There's lots of parentheses everywhere. The parentheses are dividing every block of code. So what you're seeing there, look, he just made a change, and all of a sudden, the cube that was just sitting there, it will change, and all of a sudden now it's pulsing colors. And one of the interesting features of this that makes it useful for live coding music is it's got some predefined registers in there. Here, it's a little hard to see, but he's got color vector. He's got this thing specifying in here. This input is being fed live from the audio. And this can jack into jack audio server and take audio from the source. I believe those are taken from it's taking frequency. You guys are taking frequency domains basically.
And they hold together.
Unfortunately not, but what I can refer you to is popple.org, which is you all got tablets and stuff back to and such. This is coming right off of their website. This is awesome. PowerPoint.
Yeah, it also depends on how their HD or type of quality resolution they had when they actually record this as well. Because for all we know, they could have had something super low, like 320 by 240 or 680 by 480.
Damn it, YouTube.
Now, I said this is from YouTube. This is actually from their site or their proprietary player.
Hey, but that's a good point though that you bring up, Will, because Will does a lot of recording screen captures and that sort of thing. You can set something to run and record your screen while you're doing this, produce a video like this with a little better quality, perhaps than they did.
Yeah, hence why I'm using Camtasia right now.
So anyway, so it's not as much important as what the exact code is happens to be here. But the main point that I want to get across is, oh, by the way, we're not watching a spinning cube anymore. Now we've got this thing that's actually a texture ability, and that's flashing around. And it used to be a cube, and we changed it right there on the fly. With some practice, and admittedly, I'm just beginner at this myself, so I'm just trying to pass on, if not some knowledge, at least some interest, for you guys to go look this up yourselves and play around with it. But you can start to, like anything with improvising music instruments, but you can do one level of performance for each one, like, hey, I want to play this song. And then as your skill develops, you become better at embellishing and improvising stuff. And the same sort of thing is the case here. You go from jarring transitions, oh, hey, I love this song, and now for something completely different from loading this other thing. But you can actually make it more from one to the other. And pairing visuals that make a good transition.
There's some kind of programming behind it. So
yes.
That's connecting the audio in so you have access to it.
Correct.
And
so Fluxus is a library environment built on top of Racket, formerly known as PLT Scheme. Shut it out. So the racket, like a tennis racket, is a programming language and programming language environment. It's a scheme programming IDE basically, but it's specifically designed. It was designed at University of Utah, I believe, specifically for programming language research and also for teaching people to code. Scheme was originally developed at MIT as a dialect of Lisp specifically for teaching coding. If you guys want to check out, you're familiar with the Wizard book? We mentioned in the movie Hackers. It's a Wizard book. It's freely available online. Structure and Interpretation of Computer Programs, SICP. Also known as the Wizard book. It was written at MIT in the 80s. Freely available, open source kind of Creative Commons type deal, as well as all their videos online. Damn it, internet. Yeah. Yes.
Fluxus, I saw the description in the program book. I tried to load it this morning.
It's a bear, isn't it?
Well, I loaded it at home since the internet is cheaper, but there was some problem in the boot queue. I was going to be precise.
Okay.
Again. And it looks like the project Fluxus has been a little stagnant. The last release for Ubuntu was like 2008 or 2011.
Here's the trick with that, and I'm actually in the
Well, anyway, I tried to load it, and maybe wasn't precise with some lag.
What's the internet music? I put it all in one folder.
right. So one of the things that I was hoping to get done for this presentation, and between school and work, I didn't have the time for it. Is there's no reason that this environment can't be put into like a WebGL context, where you don't have to go through that ridiculous install, and you can just fire up a browser and go to it. I think technology has only recently got to that point where that's even practical. Racket, formerly, I think it was mentioning there's some difficulty in installing it and difficulty in getting Fluxus running on top of it. I'm looking right now as far as Fluxus being stagnant, the project, I can say that's definitely not the case. The one that I've got almost but not quite working on my laptop is from their Git repository, and the last commit to that was March 14th of this year. So it's maybe not a super high velocity project, but it's definitely still under active development and maintenance. What's stagnated and suffered is the packaging. And even the build instructions on their own page, for Linux at least, are no longer accurate. But the README file that comes with the source code is. So if you download the source code, that's this is Penguicon after all right? Compile it. Let me look that up right now. The Git repository that I'm following for that is. Well, I mean, if you search for Fluxus on GitHub, you'll get it. But the particular repo that I pulled from is ZZKT, is the username. I have not, but since you mentioned that, don't think because I'm talking about Fluxus here because that's what I'm most familiar with. But there's several other live coding environments that are based on a different language, maybe a different platform, structured a little differently, maybe have some slightly different goals. But this is actually a bigger field than just, hey, here's this one program to do it.
The reason I brought that up is Super Collider, which I've done a couple of presentations on in Hackerspace, is like a do-it-yourself synth, but it has a client and a server.
Is that the one with those hex tiles?
No.
Okay.
It's like kind of like programming, but it sounds like you could do the same kind of thing with Fluxus, where you've got the client where you're doing the coding and the server that's rendering it and feeding you the video. And in the case of Super Collider, it's feeding you streaming audio based on your synthesizer design and code. So
in this case, the current architecture of Fluxus right now, it's all running in process. It's all running on the local machine. But the kind of architecture that you're describing is exactly what I'd like to do.
You could put the server on the same machine. It doesn't have to be on the internet, but when you talked about web services,
Right,
you
yeah.
can do it with a browser now.
Yeah, but I'm just saying it's not currently architected that way where there's a front-end back-end service. Thanks, guys. Appreciate it. But there are other, like I said, there are other things. There's one called Impromptu, and that is actually it's completely different from Fluxus, but the programming language is still Scheme, oddly enough.
It looked like that one of the core bets of that was that with the Fluxus setup, that every time you completed a statement that would show up as valid, it went ahead and executed it.
Yes, and that's the core. Whatever programming environment you're using, whatever language, that's a core enabler, prerequisite to be able to do this. For this to work well, you have to have a language runtime that will, compile or interpret your code in real time without having to hit compile, close it down, and start it back up again.
Well, I do a lot of programming recently, largely in Python, but I can't really see the difference between that and the compiled language for the level I'm working on, because either way it happens in seconds, and then I run it and figure out why it didn't run, and then fix it.
Well, that's an interesting point. So part of what you're talking about touches on rapid prototyping. So if you guys look up like Python RAD, rapid application development, there's there's various web frameworks. Pygame is a big one for doing audio-visual stuff with Python. And there's opportunities there for that sort of thing where you can edit a module. Let's say you've got a physics module in your game or something, and you want to change the physics of the environment that the game is. You want to decrease gravity or something. Here again, it only takes maybe a second to recompile, but sometimes even when you're closing or relaunching something, even if there was no recompile proper at all, that's still jarring you out of the flow of developing and seeing. There's a big difference between instantaneous feedback and anything other than instantaneous feedback as far as programming productivity.
The only way to improve on it that I can see would be something just like that, where it was showing you you'd have to get far enough to be showing the end result, but showing it in real time as code. So you could see that this change made had that effect.
Right. And actually, can you go back to one of those, like that second demo movie is a little more...
I can't imagine.
Sure.
Or was that the one
environment?
I think that's what we're actually looking at.
I'm a little bit confused. So to clarify, is your question how is that even possible to implement, or the question is why would you want to and is it useful?
I think the question is, why would you want to do that for general programming versus programming
or
for
perhaps a little slightly different angle? How could you do that and use it in a fashion that was useful for general programming?
In general programming, I mean, keep in mind, even with these, go ahead and fire that up, and we'll just have that running in the background while we talk. Just give a little more audio-visual interest to the presentation. Maybe you'll see. You'll see some stuff or jobs or
with an SCAD seemed to be almost the same as this. You change your little block of code and flip run and it shows you the result.
You said click run though. And that's the main point that I want to get across on this, if nothing else, is the fact that you're not clicking run, you're not recompiling, you're not doing anything. The same process.
Maybe it stages many programming of any significance where
let me put that.
It just isn't going to work until you complete a fair chunk.
Well, funny that you bring that up. So you're familiar with test-driven development?
What's good?
Test-driven development. Unit testing.
Yeah,
sort of thing.
I do that for some time.
Okay, so one of the key concepts there that you sort of touched on just now is you start with the bare minimum that could possibly even work just a little bit. And if you see, that's kind of what they're doing here, even on the artsy side, even though this isn't trying to be anything practical or useful. or accomplish anything other than entertaining ourselves and perhaps others. But that same approach to software development, where you start with nothing but like, okay, here's a stub function that does absolutely nothing, and we're going to run it every frame. And then we're going to add something that, now there's Q we can run every frame.
I do that at a little more granular level. I work in a window manufacturing plant, and we're doing a bunch of code in Python for calculating the geometric shapes, the cut parts, the glass dimensions, and there, all I do is put it in an incremental fashion, and I figured out, what the first test is for calculating the glass for an arch window. You've got the base and the two sides and the radius.
So you've got some input coming in and then you've got some output.
And you compare the test to figure out what the expected output will be for these inputs, and then you look at it till it turns out.
Right, and it's that last little bit that's the key.
That's extremely valuable when you go in there and very complex, because you start working down through the stack and you change something over here. So you run the test, and no, I didn't break it over here. Yeah, I didn't break it over here.
And that's an interesting point again that you're touching on there. You're talking about doing test, granular development, and I'm not trying to say that this particular environment or even the application is universal useful to solve every problem. Specifically, RAD is normally used for making prototypes. So you've got something that you're just handling on it basically in real time.
When you get the prototype done, you can put them out, just hand it to them to production.
Well, it's so funny that you just connected the dots right there for me, because so let's say you've got something that you're hammering on here, and let's say that this isn't just a funny little thing to keep some people amused watching a bunch of cubes spinning on the screen, but let's say we're actually doing a game, which by the way people have done with Fluxus. That was one of the first videos that Will showed you. A game for them. You can be hacking on that, and let's say it's a little less clear. Let's say you're not saying, does it pass this unit test, or does it produce this window cutting or laser cutting outlet or something, but just like, I want to fiddle with this until the game looks good, or until I have a realistic jump pattern, or some sort of realistic physics in the game, or something. And that's something where, I'll know it when I see it, and I just want to hammer on it and change things until it looks how I want it to look. And then when you're all done, keep in mind this isn't, it doesn't just vanish into the haze. There's functions where you can say, okay, save this to a file. And then you can take that file and you can compile it later or something, or commit it to source control, or unit test, or anything. So this has applicability outside of just game code and just demo. That's the focus.
But this could work, there has to be some kind of mapping from the code output to a visual audio.
Correct. So yeah, let's if we're about to.
There could be text, numbers out.
Yeah, yes. Thank you. We got our first ooh and ah from the audience. Here, cut a live code of that.
Any game CD. Brought these, got to give them out.
If you take the example of designing a program that's going to build window components, your visual could be a representation of the window components to see that your corners are matching, that the pane is matching, and as you change the code, it's stretching and modifying pieces.
Because what goes before is we make the cell is this long, and the angle is 45 degrees, and the roll burn is a 8th dimension on each end linearly, which is a bit less than the surface. Okay, now when we come up to the corners of the two arch pieces,
I think we're down a black hole of minutia here, and it's not that you don't have a good point. It's just that we're diverging a little bit from live coding to the advantages and disadvantages of rapid application in general, which we can come back to a little bit. I mean, we got tons of time, but before I bore absolutely everybody, I just wanted to continue to bore the live coding stuff.
So it's funny, in April, I submitted this
Is this the sort of thing you can implement in Python?
Yes. 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 Yeah. In general, the key thing is basically a interpreted language. And I'm not necessarily saying that you could do this with Python out of the box. Right? Because keep in mind, this isn't scheme out of the box. Either it's Fluxus or so there's some plumbing that you need to implement in order to have this feedback loop. But yes, language being capable of being a dynamically interpreted language is a precondition for that.
You could do it for one more thing, language, like Python would be.
Although I don't
by having just a layer between your editor and the interpreter.
And maybe next year I'll do a better version of this. But also, I think someone had a rapid prototyping game somewhere in there, and I was at the friends on this Oh, that's a shame because that has a lot of similarity to this in the sense of quite like putting like this. Like if you've got a game running in Python, which by the way is just Python bindings to SQL, basically, which is okay. You've got an interpreted language, you've got your visual runtime, and yeah, you can rewrite, at least in a module level. I haven't seen it happen in Python at the statement level, but you can rewrite a particular Python module in the interpreter, hit enter, and if you've got something saying every frame call this function, and you write a new function named render and hit that, that'll jump right in, and that'll be the one.
Way to do it, but they tie it under the editor. Every case will.
And that's exactly what this is. Right, so what's happening here with that is, you notice, like, you don't open a parenthesis and immediately get unclosed parentheses or something. Like, it waits till you've basically written your piece, and then it enters like that.
You can set up function-based thing. It's a little it's continuous because you got something in the background that's continually rendering.
Right.
And you're feeding it code changes, and it plugs in, and the next loop it goes through, it just repeats it.
This is anybody ever done like demos or whatever? Yeah, you just got your infinite loop basically that's running, and that's what this. It's hard to see, but basically there's a every frame macro, and you say every frame render. So you say every frame render, and that render is actually like you call it anything, I believe, but that's just the name of the function you choose to plug in. So you're seeing there, it's starting to get kind of crazy what they're developing here. And if you look at it, there's not really a lot of code that implements that. No. I mean, you got about a page, and talking about complexity and such, for this specific purpose, you do want to keep it short, because you want most of your code to be able to fit on the screen, not unless your audience can see it, and appreciate the simplicity of like, holy crap, he did that with 20 lines of code. But also just for your own sanity, being able to edit it well, and that sort of thing.
One of the bragging rights is how small to
right.
make this program. Right. Yeah. So it's 20 kilobytes long, and then it's a 30-minute.
Right. So Lisp and Scheme are famous or almost infamous for being compact in a good way, as opposed to a lot of people. I don't want to get any enemies here, but Perl, you know what I was going to say. Perl has a sort of an infamous reputation for being compact in a usually bad, hard to read sort of way. So one of the things tying back into the Fluxes Manifesto is Scheme, the language, is a very beautiful language as far as to look at. There's not a lot of different special characters. It's all just these flowing parentheses, nested lists of code. But again, you don't have to live code in Scheme. There's a very famous, I don't know why the name just escaped my brain. Anybody familiar with processing? Java-based, right? There's a processing-based live coding environment. There's also one. It's if you guys go to it's toplap.org, laptop reverse. If you go to toplap.org, they're a general site of just live coding resources here. And there you go. So actually, if you scroll all the way over to the right, I think there's some of the stuff that I talked about earlier about
Go to what? Holy Grail temperance talks. Use that.
Yeah. Well, okay. So what? But funny enough, what that's actually talking about is what I started off mentioning. What this talk isn't is the hey, I'm giving a conference talk on C# or my new Rails framework or something, and I'm going to demo in front of you all. I'm live coding my conference talk demonstration. That's what that particular article is about, by the way. But that makes a good point that this particular site, toplap.org, is about all things live coding, including some of the more artsy performance type stuff.
Super cool.
Yeah, there you go.
I was thinking that the nature of Lisp being a recursive language, or Scheme, the structures you get drawn there are kind of recursive in a way, like the spider web there.
Thank you. That's what I was trying to touch on when I was talking about it being both a beautiful and a compact, sort of beautifully compact language. And certainly that touches into it. Lisp is famous for recursion, recursive algorithms, recursive data structures, and generally the style is as much as possible to have that show through in these performances. Again, that every frame, for every frame that I mentioned is actually that's actually a Lisp macro or Scheme macro. Which, if you're not familiar with Lisp or Scheme macros and how those are different from like C++ or C macros, I couldn't do it justice in this talk, but basically C macros like dumbly expand text, and if that happens to expand to text in your source code that doesn't, that isn't valid in its context. Let's say you're using a variable out of scope. Like if I define a square macro to be, x times x, and put that somewhere where it's going to cause conflicts with something else. Scheme has what's called hygienic macros, which basically means that you are guaranteed for that to be safe to call and not have side effects outside of it. Yeah, but like I said, I can't do it justice right now in here.
I have to take some tape.
But the idea is if you look into Lisp, and it's higher order functions, so you can compose things almost mathematically. So you can take you have a function that takes a function as its input and produces a different changed function as its output. And then you can use that output. You can either call it right away, or you can use it to do something else with. You can plug it into an iterator and say, now that I've constructed this function from another function, plug it into the rendering loop, and holy crap, we have a giant recursive tree that it's using. But so if there's one takeaway, definitely let this pique your interest in Lisp and Scheme and stuff. But on the flip side, if you look at it and go, Lisp, lots of irritating superfluous parentheses, no thanks. Don't let that turn you off from looking into live coding in general. Like I said, there's Java processing-based live coding frameworks. I believe there's a JavaScript-based processing framework.
So the Java processing one is you take an argument and then plug it into an LED matrix.
No, but that sounds like a good collaboration with.
It starts mutating on the matrix.
That's an interesting point, and it's something that it's certainly possible. It would count as live coding. I think we should get together, me and Roger, we should do something. Mr. Roger's the king of Arduinos. But yeah, that's a great point that live coding, even as a performance art, is a pretty deep, broad thing, not all of which has been explored yet. So yeah, it's entirely possible to say, well, just because it's not on a full desktop machine running against a projector, that it's not live coding. One of these apps that they use, oh yeah, this one that Will's got highlighted here is a mobile phone app. Doing live coding. Someone did one with the not the Microsoft Surface, but whatever they had, the big table.
Oh, Surface.
No, was it still called the Surface? Because Surface is now their tablet thing, but you know what I'm talking about. Like
Yeah, that is that was Surface.
Huh.
They had it at CES.
Okay. Yeah, and people have done something with that. I forget where the video is, but they actually had physical pucks and tokens and stuff that they would set on the screen, almost like they were like doing a war game or something. And that was how they physically provided input to the audio output. And basically what this would do, they would have all these pucks, virtual pucks that would bounce around the surface area, and by putting different types of pieces on the board, they would have different effects. Like, if one of these virtual pucks hits this piece, it'll split into 3 different ones, or it'll bounce back, or it'll be killed, or something like that. And each one of these little pucks, as it bounced around the surface, was creating audio. So think, for example, if you've got one puck that's bouncing around the screen that's just going da da da, when it hits an edge or something, you put a chord piece down, and it'll construct a chord with that puck as its root. So if all of a sudden that little puck comes and it hits one of those pieces, it'll split from da into da da da, and then you have 3 pieces bouncing around going da 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 da. Yeah, for sure. This was a bit of an impromptu wish list kind of talk. So I figured even if it wasn't the most complete and polished thing, I wanted to kind of put the seed of interest out there. With the damn it, YouTube ads. Because that's how I got the previous panel through the sleep hacking thing. That was last year Ed just did a panel by himself. I showed up. I got interested in the sleep thing. 1 year later, we got Ed and Marie, and it's a way better talk than just Ed and 5 people in a room last year. So
how would you build a touch-free Penguicon?
Very carefully.
So that's the Surface Hockey. Now that's showing the hardware and the software that's capable of running on that. Now that's not live coding, but again, picture the fact of if moving that puck around was could be altered programmatically, which there's projects that have done that. I want to look up the name of that. Extempore. EXTEMPORE. That is it's another scheme language live code environment. EXTEMPORE. Extempore, I don't know. But that's a brand new one. Fluxus has been around for several years. Oh yeah, there we go. So this is this was an example of a project that had been kind of quote unquote dead for a long time. It's kind of risen up from its ashes, new version just out kind of thing. I haven't even gotten a chance to play around with it yet. That's on my short-term to-do list. But there's an example of it's completely different environment. Completely different environment from Fluxus, but it's still based on the same. So, because I've got live code badges, and even though it's basically the end of the conference before if you want to grab a badge and go out, please do. Get some more for next year, but I think that's really about that's about all I had that I wanted to talk about. If you guys have any more questions or just want to dig into anything else. Despite my lack of preparation, I do know what I'm talking about, so if anybody has any more questions, I'd be happy to.
But thanks everybody for coming, and I hope if nothing else, you guys get the interest to at some point, whether tomorrow or next month or something. Just Google some of these sites. Just start looking into live coding in general.
Every year there's a mobile phone concert given up at the University of Michigan for engineers and learning for creativity.
Excellent.
And this year there was some live coding.
Excellent.
Yeah.
Yeah, I know there's been some demo scenes come up from it, and that's interesting to hear. But Roger's out at